Okay, today's lesson in Investigation 2.4, we get into strategies to find solutions to linear equations. So in 2.3, we did some work with creating linear equations, actually finding strategies for them, and then today we're actually going to figure out how we can solve these linear models, either through tables, graphs, slopes, y-intercepts, kind of putting it all together again. So the scenario we are going to talk about is actually on page 40 of the textbook. Um, so you'll need to kind of read this little piece of information where Sandy's boathouse, and they use this equation 0.15 t plus 250 to find the charge of C being the cost in dollars for renting a canoe for t minutes. So take a quick pause and we'll go over. You can read that little scenario and then we'll start with the actual lesson. Okay, so now that you've read through page 40, so when Rashida and Serena applied for jobs at Sandy's, the owner gave them the following test questions to see if they could calculate charges correctly. So she wanted to explain what the numbers in the equation C equals 0.15 t plus 250 means. Well, if the 0.15 t is dealing with a variable that gives us cost, and this t is being multiplied by t, and t is in minutes. This is something about cost per minute. Okay. So obviously this is some kind of rental fee per minute. And obviously at being 0.15, it's 15 cents per minute to rent the boat. So that $2.50, which also is rolled into the total cost of renting the boat, has got to be some type of flat fee, or obviously just maybe like a maintenance fee or something like that, where it's kind of a usage charge, so to speak, to work with maintenance. All right. So now we kind of understand what the equation means. How do we use it? Well, how much does it cost to rent a canoe for 25 minutes? Well, minutes deals with the variable t. So we're going to take 25 and we're going to plug that in for t and solve for c. Okay, so when I take 25 and multiply it by 0.15, I get 3.75. Okay, and 3.75 plus 250 is $6.25. So the cost of renting a canoe for 25 minutes is $6.25. Now, they asked me to use the same equation in a different way. They said the customers charge $9.25. So $9.25 deals with the variable C, the cost. We want to know how long did they use the canoe for. So we're actually going to solve for T. So when I take my equation now, I want 925 equals 0.15 t plus 250. And now we're going to solve for t. So I'm going to move the 250 first by subtracting it. When I subtract it, I get 675 equals 0.15 t. All right, now to get t all by itself, I need to move that 0.15 over to both sides by dividing it. And when I divide it, I get t equals, so 675 divided by 0.15 is 45. And that's going to be minutes. That's how long that we rented a canoe for. To pay $9.25. Now, number 4, if a customer basically only has $6 to spend, how long can she rent the canoe for? Well, it's almost like question 3 above. And now instead of $9.25, we're going to replace the $6 in the C. So it's kind of the same question, just obviously using less money. So our answer should be less than 45 minutes. Well, let's see. Again, I subtract 250 to both sides. So I get 350 equals 0.15 t. And when I divide both sides by 0.15, t is going to equal 23.3 repeating. So 23.3 repeating is a third, right? So 23 and a third minutes. And if you really want to figure out what that is exactly, it's basically 23 minutes and 20 seconds, because 1/3 of a minute is obviously 60 seconds are a minute. So 1/3 of 60 is 20 seconds. So at 23 minutes and 20 seconds, you will have spent your $6. So if you don't have any more money, you will be in trouble because you've run out then. So have the boat back before then is the best thing I can tell you. All right. So our next part, Dave gave the owner gave Rashida a graph, the same graph that we talked about above. And now, if they were to answer those questions, how can they use a graph to answer those questions? Well, it's going to be tough to be precise in a graph. That's why they want us to estimate the answers. So if we were to answer to question number 2, which was how much did it cost to rent the boat for 25 minutes? And that was what, $9 and I'm sorry, $6.25. So for A, it was $6.25, right? For that first question, I'm sorry. This will be question A2. And then A3, that answer was 45 minutes. And the last one we just did was 23 and a third minutes. So let's see how using this graph, and I'm going to use these two lines to kind of help intersect. But the first question asked us if we use 25 minutes. If I use this vertical line, so if you were doing it with a ruler, drawing lines, I want to go right in the middle between 20 and 30 minutes. That's pretty close. All right, and then if I use this other line to kind of see where it crosses at, it crosses about right there. So you can see it's just above $6. So our estimate had to be, obviously our estimate would be it would cost a little bit more than $6. We can't be too accurate with that because we don't know. But as you can see, we're pretty close to that actual answer that we got up above using the equation, which got us a precise answer. Okay. So the second question asked us, well, if the customers charge $9.25, how long have they used the canoe for? Well, we know that $9 is literally halfway between 8 and 10. So if we go just a little further up, and now I slide the vertical over to see where it connects the line at, right there, you can kind of see it looks like it's right in the middle of 40 and 50. So our estimate would be 45 minutes. And you can see right there that we're pretty close to being, we're basically dead on there. So sometimes we come up with the exact answer when it works out really nice. Where if it doesn't work out really nice, we kind of can give it just a pretty decent estimate. Well, in the last question it asked us above about $6. So if I take this down to 6, which is right on the line here, and I drag this over to where it connects, okay, about right there, you can see that it's just past the 20, but it's not close to the halfway point at 25. So it's between 20 and 25 minutes. And obviously that line is a little bit more than halfway to 25. It's closer to the 25-minute mark. Let's say this little spot right here is 25. So it's closer to 25 than it is to 20. So we could probably say, it's between 20 and 25 minutes, closer to 25. And of course, if you remember right, our exact answer was 23 and a third. So that's how we can use the graph to estimate. All right, moving on. All right, now the owner asked Serena to explain how she could use a table to estimate those answers. Well, again, the first one is going to ask, the question asked us was, she used the canoe for 25 minutes. So in 25 minutes is actually right in the middle between 20 and 30, right? So we need to find the middle between $5.50 and $7. So if I take $5.50 and add it to 7 and then divide it by 2, that will give us the middle. Well, that's $12.50. When I divide $12.50 by 2, it gives us $6.25. And that's the actual answer that we got in the first part. So as you can see, we got a pretty accurate estimate there, don't we? Now the second part at $9.25, well, down here, $9.25 happens to be right in the middle of $8.50 and $10 because halfway between of $1.50 is 75 cents, and $9.25 is 75 cents from $8.50, or 75 cents less than $10. So what's dead smack in the middle then between 40 and 50? 45, which happened to be our exact answer for that second question they asked us up in part A. So we've used the table. Instead of finding estimates, we've actually found the exact answers. Now where that changes is the last question at $6.25, because if I erase this from the first part and say, okay, well, 625 sits somewhere in here, right? All right, and that's where we found it before. Well, at $6, it sits right in here, right? So $6 is 50 cents from here, but $1 from here. So it's really not in the middle, is it? And we know that 25 is in the middle. So this number has to sit between, obviously, 20 and 25, right? So at 25, it was 625. And so when we had 25 minutes, it was $6.25. And we know that at 20 minutes, it was $5.50. And if we're looking for $6 here, where does $6 come into play? Well, it comes into play somewhere in the middle here, but to get to $6, it's 50 cents from here, right? It's only 25 cents from there. So our estimate again would be 22.5 minutes is the halfway point. But we have to be a little bit past that, and as we knew, our answer was 23 1/3. So again, that's how we can use the table to estimate those answers. And again, 2 of them worked out really nice. 1 of them, we just kind of had to come up with an estimate. All right, part D. Now we asked Rashida and Serena to work together to find the exact answers. So in part 3, they solved that equation where they asked us to find if the customer spent $9.25. So from this gray box up above, I'll just kind of talk about it. So again, what they did was they plugged in, they had the equation, okay, from above, and from what we've used before, plugged in 925 for C, subtracted the 250. We did this work already, but again, I'm trying to show you this is kind of how they do the gray box. All right, so that's what they get right here. Then they divide both sides by 0.15 and get T equals 45 minutes. That was right there. Okay. Now, it says to check the answer, substitute 45 back in. So what they did was they took the answer here and plugged it back in for X. So when they solve this, okay, when they solve this question, they're checking their answer, okay? And we know when you check an equation, we have to have the left side of the equation equals the right side of the equation. Well, this is 675 when you multiply 0.15 times 45. And when you add these two together, you get 925 equals 925, which checks. So because we got the same answer on both sides of the equal sign, we know that 45 is the correct answer above because it checks in the equation. Okay. So now River Fun Boats rents paddle boats for people, and they use a different equation. So 4 is, again, you're basically your flat fee to take the boat out, and they charge you 10 cents a minute. Okay, so there's your charge per minute. Okay. So if they wanted the boat for 20 minutes, again, minutes is dealing with T, time. So we are going to plug in 20 for T and solve. Well, at 10 cents times 20, that's 2. And we get C is $6. So at $6, you can rent the boat for 25 minutes. Okay. Or 20 minutes, I'm sorry, not 25 minutes. So again, if a customer is charged $9, well, that $9 deals with costs. And cost is C. So at $9, we're going to solve for T. So if I subtract 4 to both sides, I get 5 equals 0.10 T. And when I divide by 0.10, now when I divide 5 by 0.10, I get 50 minutes. Okay? Which means if I pay $9, I get that boat for 50 minutes. Which is a better deal than the other place because at 45 minutes, I had to pay $9.25. So I'm paying a quarter less, I get the boat for 5 more minutes. That's a pretty good deal for me. So if we want to spend $12, how long you can use the paddle boat for? Well, I know up here, when we spent $9, it was 50 minutes. So I know if we spend 12, I should have an answer of more than 50 minutes, right? So if I plug in 12 to my equation and solve for t, okay, subtracting 4 to both sides gives me 8, and I got 0.10t on the other side. When I divide by 0.10, all right, t equals 80. That's 80 minutes. So if I spent $12, an hour and 20 minutes of canoe time I get, okay, that's a lot of rowing. But again, it should be more because, again, we're spending $3 more. We get the boat for 30 more minutes. That's a pretty good deal. All right, moving on. Now dealing with graphs. All right, so the graph that you see over here represents a helium balloon flight. So here you got your time going up by ones. Here you got your height going up by 1,000. So as you can see here, they want us to determine the rate of change. Well, at 1, we are at 1,000. All right, at 2, we are at 2,000. At 3, we're at 3,000. At 4, we're at 4, and so on. So every time we go up a minute, we're increasing by 1,000. So our rate of change is the change in y over the change in x, going by 1,000s to 1. So that's 1,000. Oops, not a dollars. That's 1,000. Okay, our slope is 1,000 feet. So what does this mean? So basically, for every 1 minute, the balloon rises 1,000 feet. That's what it means to this situation. And again, when is the balloon at 5,000 feet? Well, right this point, which is at 5 minutes. And where is that on the graph? I'll just put a green X to it. It's right there. All right. So D is a typo. How high is the balloon off the ground at 2 minutes? Okay. Well, at 2 minutes, that's right here. And that's at 2,000 feet. So we figured out that for every 1,000 feet, right? So our equation is this, basically. There's no y-intercept because if we don't let the balloon go, it doesn't go anywhere. So if we wanted to figure out how high the balloon is at 10,000 feet, we're going to plug 10,000 in for y and solve for x. Well, I just divide both sides by 1,000. And again, this becomes 1. When I divide base 10 numbers and I see the zeros here, I can just cross out the same equal amount of zeros. And I'm left with 10 over 1, which would be 10 minutes. So our answer to that question is it would take 10 minutes to be the balloon for it to be 10,000 feet. All right, let's go on to another graph. The next graph shows that Brady's savings account. So we can see for every 1 month, all right, the account goes up by $100. You can see it increasing by hundreds. So at 1 month, we're at 400, at 500, 600, and 700, and so on. So the slope of this graph is $100. It's going up by $100 every time. Okay. So the slope means for every 1 month, the savings increases by $100. Okay. So how much did he deposit when he opened the account? What did he start with? Well, that's this point right here. And that point right there is $300. So he started his account with $300. And then from there we go up. Okay. So at 12 months, we're at $1,500. Okay. Which means at this rate, at 15 months, how does it go? Well, to get to 15 months, that's an addition of 3, right? So if we're going $100 per month, that means this point to go up to 15 months has to go up $300, right? So if you add 300 to $1,500, that is $1,800. And again, we've already found out an equation for this because we know what our y-intercept is. That's the 300, right? Our slope is 100, so you could have even found out the equation and plugged 15 in for x and solved for your cost, y. Okay, but $1,800 was our reasoning there. All right, moving on down. So Rowan makes a $7 an hour babysitting, so he wants to create a table. Well, if he doesn't babysit at all, he doesn't make any money. And then per hour, he makes $7. So at 1 hour, he makes 7. At 2, he makes 14. It's increasing by 7 every single time. Okay. So again, the equation represented in this graph should be this. And our rate of change is $7. Because for every hour he babysits, it told us that right in the first sentence. So again, what does this mean to our situation? All right, for every hour that he babysits, he earns $7. So since our money made is dependent upon time, our time variable is down here, and our money is right here. So again, if we go by 1's down here, and I don't know, get to 35, we could go by, I don't know, 3's. Excuse me. I get an idea. So at 0, obviously 0, 0, 1, 7, which is going to be like right here. 2, 14, it's going to be right there. 21, which is right here. 28, which is just above. And then 35, which is going to be like somewhere about here. And our line. Obviously, if you use a greater scale, like going by 5s, the line will flatten out a little bit more because you've got a greater scale, but you get the idea of what our line looks like. It's linear because constant rate of change of plus 7. All right, on to the last part here. So if it costs $25 to rent a car and 10 cents per kilometer to drive, create a graph. Well, this is a big thing here. So even if you don't drive the car off the lot, it still costs you 25 bucks. So if you notice this point here, remember, cost is dependent upon distance. So this is our x. This point here is our y-intercept. All right, so we are starting at 25. So if I go up by 5s here, that's our starting point. Okay. So if I know what my y-intercept is, 25, and this number represents cents per kilometer, so that means this is my slope. So my equation basically for this graph, again, we can just plug in y equals mx plus b, is this. So when I multiply 10, 10 times 10 cents is 1. So this becomes 26, 27, 28, 29, and 30. When I plug in these numbers right here, I'm plugging these numbers in for x. So I don't get a very big increase, do I? So if this is my distance, here's my cost, and here's my distance in kilometers. Okay, I don't go up by very much, do I? I mean, this line is going to be pretty flat because at 25 or 50 way over here, I mean, this line, you can see the points in between is going to be super, super flat because we're not increasing by very much. Okay, because we're only, again, for every 10 kilometers that we are driving, we are only going up by $1. So to answer some of these questions below, we found the rate of change of the graph, right? The rate of change of the graph is 1. It's the cost, so the cost increases by $1 for every 10 kilometers driven. And 1 divided by 10 is 1/10, so it's still our same slope. What is the value on the y-axis? Well, again, that point is right here, because this is the y-axis, is right along the top line here. That's $25. And $25 relates to the cost of just taking the just getting the rent-a-car itself. So again, if you don't even drive at the lot, 25 bucks. So again, that's obviously going to cover maintenance and gas and all that stuff. So if we paid the same fee, but more per kilometer, what would this line look like? Well, what would happen is I'm going to draw it in green, but this line would get steeper. So this line would start to, depending on the increase, it could look like this. And obviously the higher it goes, that line would get steeper and steeper, okay? So again, as the slope increases, the steepness of the line increases. As the slope decreases, the steepness of the line decreases and actually can go negative. All right, so that's how the slope works for a visual on the graph. So the next graph, we don't even have a label for it. We just know that there's number of weeks and books. And if you look at that line, it is dead straight. So again, we've always said the slope of a horizontal line is 0. So what does the slope mean? For every week goes up by 1, the number of books read stays the same. So this person's reading a really long book. All right. So how many books are read in 2 weeks? 1. How many books are read in 8 weeks? 1. So this poor guy is never getting past this book, and I guess after a while you might as well just give up, right? But that's what this graph is saying, which is kind of odd. But again, sometimes graphs, again, is just reading what the information is there and not trying to look too much into it. All right, the last graph deals with distance and cost. So notice that this graph right here, this little spot, we call this a break. Because if you notice, the very first line starts at 14. So it's obviously so we started up that higher to get all of our data in. All right, so that's what that is. So if you notice, the cost is still going up by 1. The distance is going to the right by 1. All right. So if I go from this point here to this point here, it's an increase of 1.5, and it goes over 1. So our slope, rise over run, is 1.5, which means for every mile, and again, there's no title here, so we don't know if it's driven or walked, but for every mile, actually, let's make a better sentence here. How about this? As miles increase by 1, cost increases by $1.50. Again, what is the cost? The distance is 0. Again, that's the point right on the y-axis, which is right there, which is 15. Okay, so again, distance is 0. That's our x. We're talking about our y-intercept here. And it's very important that you understand on graphs, where is that starting point? Where is the y-intercept? All right. So this is our homework assignment. Okay, we can pause the video here and hope you found this lesson to be enjoyable. So pause the video so you can write this down, and hope you found this lesson helpful.